I am going to create a very important experiment in science for you in the form of an animation in PowerPoint. So follow me to the end of this educational clip. I have already prepared the necessary tools and equipment for this test. You can design your images with the powerful Illustrator software and easily insert them into PowerPoint. Of course, you can design them with PowerPoint. But some are very difficult with PowerPoint, such as the picture of the great scientist Ohm, which I designed with Illustrator. How do you design this ammeter with Power? Well, I will teach you an easy way to design the grading section with the help of PowerPoint tools. Now see how easy it is. Change and color the shape of the ammeter to your liking. And the distance of degrees is very accurate and the same. The art of design depends on your creativity. PowerPoint has enough tools for simple designs. I didn't design the ammeter hand before because I want to design it with you and animate it later. With the help of a triangle, I draw the hand and put a small circle on the end of the hand. Because I intend to give the hand rotation animation, it is better to make a copy of it and change it by 180 degrees and remove the background color of the copy hand. You will understand the reason for this later. I take a copy of the ammeter pointer and add this new pointer to the voltmeter. Choose the freeform tool and connect the connecting wires between the devices and try to complete the circuit correctly and scientifically. As you know, the ammeter has almost zero resistance, and the voltmeter, on the contrary, has almost infinite resistance. That is, the ammeter completely passes electric current, but the voltmeter does not pass any electric current, so the ammeter is sequentially and the voltmeter is we put parallel in the circuit. I draw the wires temporarily and may change them later. I connect the red wire to the positive pole of the battery and the blue wire to the negative pole of the battery. Now I want to design the connector wire sockets with the help of PowerPoint. It's very easy. I continue my design with a rectangular shape and make my design more beautiful with a little color gradient. Okay, I'll take a copy of it and change its color to blue. Copy the sockets and complete the electrical circuit. OK, now with the help of the freeform tool, connect the electric current connecting wires to the sockets. Be careful to connect the wires of the voltmeter to the resistor because the voltmeter has infinite resistance and does not allow current to pass through itself. You can use the Edit Point tool to change the length of the interface wires. As I said before, I may change the connector wires. My electrical circuit does not have an electric current cut-off switch, so I have to design a cut-off switch. I must make sure that the cut-off switch is animated. The black part is electrically non-conductive and the pink parts are made of metal and is electrically conductive. I have designed the carbon resistor that you see in the electric circuit with PowerPoint. There are different ways to design it. For example, you can design the base part of the resistor from a rectangular shape with rounded corners. I have designed the lamp hanging from the ceiling with PowerPoint. From the simple shape used, a little creativity and patience is required to design any shape in 2 dimensions. Okay, now you need to add your desired animation to the objects. Of course, be careful to follow the scientific rules. The main applications of Ohm's law are, to determine the voltage, resistance, or current of an electric circuit. Ohm's law maintains the desired voltage drop across the electronic components. Ohm's law is also used in DC ammeter and other DC shunts to divert the current. Ohm's law is one of the most important equations when it comes to understanding electric circuits, but if you're going to understand it, you'll need a good grasp of the basic concepts it links: voltage, current, and resistance. Ohm's law is simply the equation that describes the relationship between these three quantities for most conductors. Voltage is the most commonly used term for the electric potential difference between 2 points, and it provides the push that allows electric charge to move around a conducting loop. Electrical potential is a form of potential energy, like gravitational potential energy, and it's defined as the electric potential energy per unit charge. The SI unit for voltage is the volt, V, and 1V equals 1J/C, or 1 joule of energy per coulomb of charge. It's sometimes also called electromotive force or EMF. Electrical current is the rate of flow of electrical charge past a given point in a circuit, which has the SI unit of the ampere, A, where 1A equals 1C/S, 1 coulomb of charge per second. It comes in the form of direct current, DC, and alternating current, AC, and although DC is simpler, AC circuits are used to supply power to most households around the world because it's easier and safer to transmit over long distances. The final concept you'll need to understand before tackling Ohm's law is resistance, which is a measure of the opposition to current flow in a circuit. The SI unit for resistance is the ohm, which uses the Greek letter omega, where 1 omega equals 1 V/A. Thank you very much for watching this educational video.